to talk to you a bit about a project which I am leading at the moment at the Ada Lovelace Institute, the organisation for which I work, which is dedicated to interrogating a different aspect of AI's potential impact on the world and indeed on health, and which for the most part I think uses quite a different toolkit to the one that you normally get within bioethics conversations. So, rather than talking about AI's intrinsic properties and the questions that those pose, so questions about dignity, solidarity, equality, etc., I'm going to be talking about what happens when this technology is deployed to enhance the capabilities of another highly ethical challenging field of science, which is that of genomics. And instead of going through some of the foundational ethical questions posed by the prospect of AI-powered genomic science, what I want to do is paint a picture of how different kinds of actors might behave should some of the predictions about AI-powered genomics come to fruition. And in so doing, I want to construct one very limited and highly speculative vision of the future, whose ethical characteristics we can then assess. But before we get into all that, it's probably worth me saying a bit more about who I am and where I'm from. So my name's Harry Farmer, as already been said. I'm a researcher from the Ada Lovelace Institute. For those of you who haven't heard of the Institute, which I imagine is quite a few of you, given that this is a Catalonian audience and given we're a relatively new foundation from the UK, the Ada Lovelace Institution is a London-based research institution, and we have a mission to ensure that data and AI work for people and society. And in practice, that means that we investigate the societal, the ethical, and the policy implications of emerging digital technologies. And we work to develop evidence and make recommendations as to how these implications might be better understood and navigated by policymakers, by practitioners, and by others. So our work at the moment spans 5 programs. So we've got one program on biometrics, which I was working on for a lot of last year, and incidentally, we've just put out a big research paper looking at the legal and the ethical challenges posed by biometric technologies, particularly facial recognition, but not limited to facial recognition. And for anyone interested in some of these perennial debates about how technology makes human bodies legible, both to one another and also through the lens of technology, I'd really recommend checking that out. There's a legal review called the Ryder Review and a paper called Countermeasures. There's also a program that we've been doing around the future of regulation, and this pays a lot of attention to emerging attempts to regulate artificial intelligence, so particularly looking at emerging attempts within the United States and also within the EU. We have a program looking at ethics and accountability in practice, which is aimed at practitioners, tech companies, those operating at the business end of artificial intelligence and database technologies. And then we have a program on public sector use of data and algorithms. And finally, there's the program that I currently work on, which is health data and COVID-19. And it's one of the projects within this work stream that I want to talk to today. So, since the start of this year, I've been leading a program of work called AI and Genomic Futures. And this is a program that we're undertaking at the Ada Lovelace Institute in partnership with our sister organisation, the Nuffield Council on Bioethics. And this is investigating the ways in which AI is poised to change genomic science and exploring the ethical, societal, and political economic consequences of this transformation, if and when and how it should emerge. So what I want to do today is tell you a bit about this project, why we're doing it, the questions and uncertainties we're hoping to shed some light on, that we're hoping to clarify and elucidate, and the specific methodologies that we're going to be using. But perhaps more interestingly, I want to take you through a worked example of the questions that we're going to be considering and the reasoning we're going to be applying to think about these. So the program came about because across our 2 organisations, the Nuffield Council on Bioethics and the Ada Lovelace Institute, we were, from our various stakeholders, hearing more and more about how important AI and genomics were becoming and were set to become to one another. So in one direction, we were hearing about how new advances in genomics were being made possible by the deployment and the development of AI, and particularly by developments in machine learning and deep learning. And in the other direction, we were hearing about how genomic science was increasingly being used and sought after as a really rich source of data on which to train AI systems. Now, on the face of it, what we're seeing, therefore, is a convergence of two of the most potentially transformative technologies of the 21st century. And to us, this seems hugely consequential. If you consider these two technologies in isolation from one another, you already quickly run into profound questions concerning agency, privacy, equality, bias, and power. But if you then look to combine those two technologies, think about how they are developing together, the questions you might ask become suddenly all the more complex. You have to start considering a number of different ways these technologies might develop and interact with one another, and also how they might interact with uncertain outside factors. And as we could see at the time, lots of good work was being done and still is being done, looking separately at the implications of AI and also at the implications of genomics. But there seemed to be less work, though by no means no work whatsoever, decidedly looking at how these technologies might develop together and in interaction with one another. And this struck us as a relative gap in the market that we were well placed and very incentivized to fill. So, the project that we have developed sets to answer three broad questions. The first is really an empirical question. This is aiming to help us develop a clearer understanding of how advances in AI, and especially in machine learning and deep learning, are changing the capabilities and applications and indeed the practice of genomic science. Then there's a more speculative, exploratory question about what might be the potential societal, political impacts of these trends, of these capabilities and these applications. And then finally, I think there's a normative question, a question for policymakers, which is what should we do given these possible trajectories that we've outlined, given these possible destinations, given the way that the world might look as a result of AI-powered genomic science and its widespread adoption. Now, in terms of the scope of this project, both genomics and AI are hugely expansive technologies. The terms are used in very, very diverse contexts. They're used very expansively. And it quickly became apparent to us that we couldn't look at the entirety of either of those terms when setting out this project. So what we've had to do is somewhat artificially restrict the scope of the project. So a few things to bear in mind with the scope of what we've been considering. We're looking at genomic analysis as opposed to genomic editing, so there isn't a huge amount of discussion about far-off things, about, say, for instance, CRISPR-Cas9. We're interested in the analysis of the human genome as opposed to the analysis of genomes of non-human animals, and critically, the analysis and the tracking of diseases using genomics. And there are some ways also that we wanted the scope to be broad. So we're concertedly not just interested in genomics in medical contexts. We want to understand how genomic science might be applied across multiple domains of life, be that criminal science, criminal justice, be that within recruitment, within sports, be that within dating. So we're just thinking of many, many different contexts in which genomics might be applied. Now, in terms of how we're going about things, the methodology for the project, we've divided the project into three broad phases. So firstly, there's a research phase, which attempts to answer the empirical question that I was setting out. We've just conducted a pretty expansive lit review, looking at the state of academic literature on AI and genomics, and this covers both the technical status quo and also the status of the legal, the ethical, and the policy debate. We're about to embark upon a bibliometric analysis. So we've commissioned an outside organization called Nesta to use data science techniques to identify trends in AI and genomics, which may be only visible at the macro level. So trends that we may not be able to identify either through reading through existing academic literature or talking to existing experts in the field. Stuff that might be flying under the radar. And we're also going to be doing some horizon scanning, specifically using something called the Delphi method to ask in an anonymous context various technical experts what they think the breakthrough changes in AI and genomics are likely to be over the next 5 to 10 years. And having identified what we hope will be a list of potentially transformative changes at the intersection of AI and genomics over that time period, we're going to be embarking on a sift phase in which we identify what look to us to be the most likely and also the most potentially impactful challenges and changes identified. And then we're going to be taking these through to what we're calling the exploration phase, in which we tackle the future-facing question and some of its normative corollaries. So we're going to be doing some scenario mapping in which we attempt to plot different possible worlds that might come about as a result of the wide-scale adoption of AI-powered genomic science, both within medicine and in other contexts, and this is factoring in lots of outside uncertainties. We also want to be involving some deliberative public engagement, so getting members of the public into a very specific controlled context, having them debate through the possible worlds that might be created by AI genomic science, and getting them to think about what their priorities, what their asks of government, of regulators, of practitioners might be, given these different possibilities. And finally, we want to be doing some gap analysis and policy development, so attempting to think about the gulf between what the public might expect of the deployment of these technologies, what the public consider to be the ethical deployment of these technologies, and where it seems that we are heading given current regulatory and legal and normative circumstances. So that's the plan for the project overall. Now, right now, we are here. We're 6 months into what is going to be a 2-year project overall. We've just completed the literature review, but we still need to collect more empirical evidence, and we've yet to start systemically interrogating the implications of what we find. Given this, there is a limited amount that I can say about what we've found so far in terms of the empirical exploration of the project. So instead, what I'm going to do for the remainder of this talk is speak through some of our preliminary thinking on one small but important subsection of our work, which is the question of how AI-powered genomics might impact upon healthcare, and specifically how AI-powered genomics might impact upon the political economy of healthcare provision. So I'm going to be speaking to broadly 2 questions. Firstly, I'm going to be talking about the ways in which AI is set to influence and is already influencing genomic medicine. What are the things that genomic medicine might be able to do better or differently or with lower cost than currently? And secondly, I'm going to then be talking about how might the enhanced capabilities of genomic medicine change the ways that we deliver, fund, and think about healthcare, particularly in Western countries. So, firstly, turning to this empirical question of how AI is influencing genomics and genomics in clinical contexts. At the moment, I'd say there are 3 main ways that AI is and is expected to enhance the capabilities of genomic science. The first way is that AI is contributing to genomic science by making necessary data collection easier, faster, and more effective. So there's a lot of hope and expectation around natural language processing, being able to speed up the digitization of medical records, which are required for genomic analysis, and also for generating more diverse phenotype data, which is also required for doing genomic analysis. And there's also talk about how AI is leading to faster, more accurate genomic sequencing. Obviously, big caveats around this, but there is expectation and hope amongst some in the field. The second way, I think is the most direct way, is by enabling better analysis of the human genome directly. So here we're seeing potential improvements in variant filtering and effect prediction, also potential improvements across pharmacogenomics, and in this context, we're really interested in the ability of genomics to better predict drug responses according to different genotypes. So understanding how I, with a particular genotype, might react to a drug differently to any one of you with your different genotypes. Also potential advantages and advances in population genetics, and also advances in polygenic risk scores. And here some machine learning models are thought to be able to improve the predictive accuracy of polygenic risk scoring. Then the third way, which is really quite a downstream way, is by making it easier and more practical to apply genomic insight in clinical contexts. And this may be through more effective clinical decision support systems, so helping non-specialist clinicians and doctors make decisions which are informed by the products of genomic analysis. And also clinical genomics results feedback, so helping clinicians communicate the implications of genomic analysis to patients. Now, there are obviously a big question marks that hang over a lot of these capabilities and a lot of speculation about these capabilities. Question marks around the accuracy of predictions that may result from genomic science, particularly with things like polygenic risk scoring. There are also big question marks, and you get this for all predictive analytic systems, around the representativeness of genomic data sets, and therefore questions around differential accuracy, around problems of bias within genomic analysis. And you also have problems around the ethics of delegating particular clinical decisions to AI-powered support systems, questions around the transparency, the accountability, the legibility of these decisions being made. And you also have ethical questions, very similar ones, around using these systems to help communicate diagnoses or prognoses to patients. But if we put a fairly large, fairly artificial pin in these concerns for a second, if we assume that with sufficiently large, sufficiently representative data sets, we can eventually resolve the accuracy and bias problems, and if we assume AI systems can one day be made trustworthy guides to genomic insight, what might the application of AI to genomic analysis provide healthcare systems with? I think in the best case scenario, the most simple best case scenario, AI-powered genomics could provide healthcare systems with one, better understanding of people's genetic risk factors for particular diseases, for particular lifestyle inputs. Secondly, better understanding of how people will respond to different medical interventions, and particularly drugs. And thirdly, and I think related to these two things, the ability to develop and deploy this insight cheaply and quickly within healthcare and within clinical contexts. So the question at this stage that we can ask is, what might the ready availability of that kind of knowledge and that kind of capacity do to healthcare provision? To answer this question, I think firstly we need to establish a couple of things. So one, we need to establish some of the defining features of healthcare systems in the West, in developed countries today. And secondly, I think we need to make some explicit assumptions about how the pressures and incentives that healthcare systems are sensitive to and the way that they might respond to the emergence and the availability of new technological capabilities. So let's take these two things in reverse order. What sorts of assumptions, firstly, might we make about the ways healthcare systems could change in response to new technological capabilities? I think there's a first cluster of things which I would implore you to kind of consider here, which is I think we need to make some assumptions around the ways that new technologies are adopted, deployed, and regulated in capitalist systems. So one thing that I think is important to keep in mind here is this idea of the line of least resistance, which says that in the absence of very strong countervailing forces, new technologies aren't generally deployed in ways that necessarily make best use of their potential. Instead, at least initially, they will get deployed in ways that are most readily compatible with the existing economic order and, crucially, least threatening to existing vested interests. And this is an idea that has been really well articulated by the philosopher and statesman from Brazil, Roberto Ungar. I think there's a second point which is related here about socio-institutional inertia, and this is the idea that it can take a very long time for socioeconomic systems to reorientate themselves to fully capture the potential of new technologies. This is something that economists like Carlota Perez and Mariana Mazzucato have written really extensively and interestingly about. And finally, and relatedly, I'd say that some of the early ways that technologies are adopted can be very difficult to reverse. Once technology gets embedded within the system, within a particular way, it can be very, very difficult to reverse that particular form of deployment of the technology through state intervention, so for instance through regulation. And this is the famous basis of the Collingridge dilemma from Daniel Collingridge in his book, The Social Control of Technology. So I think if we take these three things in combination, we see that technologies don't necessarily take forms which are societally beneficial without strong intervention initially, and it can be very, very difficult to reorientate them towards different applications once they have been embedded within socioeconomic systems. So a bit of a word of warning there. So secondly, I think we need to make some more contingent political and economic assumptions. So I think it's fairly safe to say that we can expect healthcare systems in the West to continue to operate under financial pressure, and in some cases extreme financial pressure, in the short to the medium term. I think also we can say that a lot of AI and a lot of genomic capacity is going to be deployed and held by the private sector, even if it's funded and deployed, at least initially, by states and by state funding. And finally, I think there is this perennial, this long-standing debate around the trade-off between, on the one hand, the exploitation of personal data, and on the other hand, protection of people's individual privacy, people's agency over their data, and in this case, genomic data. And I think in the absence of some big changes, and obviously there are big kind of regulatory forces trying to push in the opposite direction, but I think unless these get a lot stronger, we can expect that trade-off to be increasingly resolved in favour of the exploitation of people's personal data rather than the protection of privacy. So a slightly pessimistic assumption being made there. And finally, I think we need to say something about some of the most important background conditions, so some of the environmental and demographic background conditions in particular. So fairly obviously, ageing populations, I think, are going to put a strain on healthcare systems and welfare provision in the developed world and in the West. And in combination with this, I think we're going to see global heating, the climate catastrophe, probably leading to a slow but steady increase in resource scarcity. And I think this is going to have a particularly acute impact on healthcare systems, particularly in Europe and in parts of North America. We're going to be seeing increasingly hot summers putting a strain on the healthcare systems. So, having got those assumptions in mind, now let's look at some of the features of healthcare systems in the West currently. So I think there are a few things we can say here. In terms of what healthcare systems currently provide, I think it's worth saying healthcare systems are still by and large focused on treatment rather than the prevention of diseases. There are obviously, and there have been for some decades, attempts to reorientate healthcare systems towards prevention, but suffice to say we're not there yet. Most healthcare systems are still fully on a reactive footing. That's the way they have been designed for decades and decades. And we can also say that resource allocation is done according to utilitarian considerations, but it's not particularly granular. Resource allocation assesses the impact of investment in particular interventions rather than looking at the particular people to whom those interventions go and assessing the health economic case of intervening in particular cases. In terms of what healthcare systems require of patients, if you're not interacting with healthcare at the moment, not directly interacting as a patient, healthcare services don't typically require much data about you. Of course, if you're being treated, the data that you use is required, but it's limited to what is immediately relevant to your healthcare. And we also see at the moment with public health measures, these typically are conducted at the population level. Everyone pays more for alcohol, for tobacco, subsidies for healthy foods apply to everyone. Everyone was encouraged to get exercise and get vaccinated. It's a one-size-fits-all to public health, by and large. In terms of who's involved with paying for healthcare and providing healthcare, I mean, there is infinite variety within the West, but at the moment it is still possible for states to provide healthcare without the help of the private sector. There are obviously some big caveats to this, and I think pharma is a big exception to that rule, but by and large it's possible for states, therefore, to retain control over the terms in which they are providing and offering healthcare. In terms of how healthcare is funded and justified, currently provision of healthcare is justified generally in one of two ways. So in public healthcare models, so those like the National Health Service in the UK, where healthcare is paid for through general taxation, or in states where healthcare has compulsory health insurance, so what you might call kind of social insurance models. Healthcare provision is by and large based on a principle of solidarity. We pick the system from what you might call a kind of veil of genomic ignorance, to borrow Rawlsian terminology. And none of us know whether we're going to need medical care, so we all pay into the system. We agree to socialise the risk. Whereas in private insurance-based models, where you can choose whether or not to have insurance, there is a model of cross-subsidisation, whereby those who don't require healthcare subsidise treatment for those who do. People can't rule out the possibility of getting it in the future, so they get insurance. People who don't end up needing the insurance get it anyway. They effectively pay for those who get insurance and don't need it. So these models work differently, but they are both, I think, to some extent, dependent on citizens making hypothetical, rational decisions given limited knowledge about their future healthcare needs. And it's that question and the question of what changes should that knowledge become less limited that I want to turn to in a second. But more generally, I think the question, with all these assumptions fixed, to ask is, how might the enhanced genomic capabilities that we've talked about affect each of these features of healthcare systems that we have currently? How might the ability to assess and predict people's medical present and future strain these arrangements that we have developed over the past few decades, given, as we have acknowledged, the tendency to keep power structures and arrangements intact? So, I think the first set of conceivable changes is around what healthcare services provide. And I think the first cluster of changes here, I think we could call towards precision prevention. At the moment, healthcare services are still, as I said, more orientated towards the treatment of diseases and poor health, rather than towards prevention. There have been long-standing efforts, as I said, to put health services on a more preventative footing, but there are hard limits to prevention currently. Prevention requires environmental change. It requires making our lives better beyond the domain of healthcare, and this is expensive and difficult, and therefore doesn't command universal political support. And in virtue of being untargeted, prevention has a problem at the moment that it both underextends and overextends. It requires a big imposition, potentially, on healthy people who could probably get away with some unhealthy habits, could get away with being taxed less for certain things. And it probably doesn't do enough for people who are at risk of certain diseases through lifestyle factors and who are put seriously at risk by these things. But if medical science reaches a point at which genomics provides a far better understanding of what diseases and what conditions individual people are at risk from, a better understanding of how different people respond to particular environmental stimuli, to food, to exercise, to stress, to sleep deprivation, for instance, it becomes suddenly much more viable to tailor people's surroundings and lives towards the prevention of illness. Prevention doesn't necessarily, at this stage, require sweeping changes to all of our environment or to the economic status quo. Instead, healthcare systems can assess who is at risk and who isn't, and target preventative measures to those people and only those people who are seen to require them. Now, in practice, this would entail public health initiatives becoming highly personalised, and I think from where we're standing at the moment, that seems pretty unpalatable. But if you think about a world in which there is an abundance of genomic data, an abundance of insight, an abundance also of data about people's healthcare habits, coming through things like wearable devices, through the Internet of Things, and if you also think of a world characterised by scarce healthcare resources, this shift, which you might call the shift towards precision prevention, suddenly becomes a lot more credible. I think the second change you may well see is in terms of resource allocation decisions. So currently, resource allocation decisions are not made at the level of individual patients. Drugs and medical technologies are allocated on assessments of their relative efficacy, relative effectiveness for the average patient. But with the ready availability of genomic insight into how different patients might respond to different interventions, doctors can potentially decide whether or not to prescribe a particular drug or a particular intervention, factoring in a patient's genetically determined likelihood of responding well to it. I'm going to jump ahead to what is slide 24, which is this question of what the availability of genomic insight of the kind that I've described adds up to. This is the availability of far more granular, far more detailed insight into people's medical future and people's medical present. I think there are a few characteristics, which I would have explained, that we can say about this potential future. And the real caveat here is this is one of many different potential scenarios. But on this one, following along from a lot of the assumptions which have been made before, I think we see a world in which healthcare has become, because of these background assumptions, very expensive, and therefore we have a lot of energy on the part of healthcare and a part of more society in general devoted to avoiding having to get to the point of healthcare interventions in the first place, and it's a source of extreme societal anxiety being on such a preventative footing. I think you also see, because genomic insight and genomic analysis is something held primarily by the private sector, because AI companies and the sorts of predictive analytics that they provide, which are necessary for genomics, that's all held privately. In this world, we see that there is a high degree of private control over healthcare systems. And to some extent, we might worry about this undermining democratic accountability and public value for these systems. If it's impossible for healthcare systems to do what they do without the help of, for instance, the data coming from Apple Watches, without some of the analytics services provided by big AI and genomics companies, this is a very different proposition for the sorts of options we have as democratic states in terms of how we want to provide healthcare. I think you also see, on the part of individuals, a lack of de facto agency over genomic data. Genomic data sharing becomes part of the trade-off, part of the explicit quid pro quo. It's expected that people, if they're going to be drawing on healthcare resources, need to be sharing their genomic data. They need to be paying into the system if they want to take out. And I think in a very similar vein, on a similar note, taxpayer funding of healthcare becomes harder to justify due to a breakdown of solidarity amongst citizens. Genomic analysis has provided an insight into who is likely to require healthcare resources over the course of their lifetime and who is unlikely to need many healthcare resources. I think one of the upshots of this feeling of lack of solidarity between the genomic haves and the genomic have-nots is a kind of unevenly applied paternalism. Some people are subject to a lot of constraints on their lifestyle because they seem to be at risk of particular health conditions, whereas other people aren't subject to those same constraints. And this is within the context of constant monitoring of health, with genomic losers, or those who have poor genomic prognosis, most subject to these monitoring and lifestyle requirements. And you have this dynamic whereby these genomic net contributors will only tolerate paying for these net genomic recipients if recipients are seen to do everything they can to minimize their genomic risk factors through adaptations to their lifestyle. And finally, I think you have, because of genomic insight through pharmacogenomics, because of the ability to understand how different people at an individual and fairly granular level are going to be responding to pharmacological interventions, to having been prescribed drugs, the threshold at the margin for drug prescription becomes a lot lower. So mass prescribing of particular drugs, be they for physical or for mental health problems, becomes a lot easier to justify and potentially becomes a lot more common. I think of also you factor in resource scarcity, the fact that other kinds of interventions may be comparatively more expensive than pharmacological interventions. I think, again, that's quite credible in the particular scenario that we have been constructing here. So I think the question we need to ask about this world is fairly simple. Are these circumstances that we've set out ones in which it is possible to apply bioethical principles at a micro level? Can we apply in this world, with any real chance of success, principles of agency, solidarity, privacy, autonomy, dignity, and equity? And if we can't, if we're not confident that we can really have these principles applied purchase in a world that looks like that, what can policymakers, regulators, healthcare providers do differently to ensure that healthcare systems deploying genomic analysis take a different form to the one that has just been outlined? And this is one of the questions that we're going to be working on at the Ada Lovelace Institute and the Nuffield Council on Bioethics over the next 18 months. And it's on that question that I will bring things to a close and open the floor up for discussion. Thank you, and apologies again for taking so long.